Alright, so for radians and degrees 1.4, we're going to talk about first the standard position of an angle. So the standard position of an angle assumes that you're going to start at the positive x-axis. So that's what this right here says. The initial side lies along the x-axis. So that's the initial side right here. And here's the vertex. So what you're going to do is you're going to take this red segment and you can rotate it about the coordinate. So if you go this much, for instance, you've gone 90 degrees. So there's a whole bunch of them, and we're going to figure out how many there is, or not how many, but where they all are. So if you think about where they all are, if you're talking about a coordinate plane, we talk about quadrant 1, we talk about quadrant 2, we talk about quadrant 3, and we talk about quadrant 4. So our first quadrant 1, if I have an angle, then it's going to be anywhere between 0 and 90. So let's just take this for instance. This could be 60 degrees. That's in quadrant 1. If I do a different quadrant, let's do quadrant 2. So quadrant 2 starts at the positive 90 degree and it goes to the 180. So an example that I could be in quadrant 2 would be, say, 130. This would represent a standard angle of 130. So quadrant 3 could be anywhere between 180 and 270. So for example, you could have an angle that's here. That would represent an angle of, say, 260. And these are just examples, of course. You could have, anything between 180 and 270. And then for our last example, I'll do something in quadrant 4. Oops. Quadrant 4 is anywhere between 270 and 360. So this is a really big angle. It kind of looks funny, but something like this, and you're actually saying that this is the angle, kind of looking like Pac-Man almost. So that could be, say, 300. Okay. So a positive angle is measured in the counterclockwise direction, and a negative angle is measured in the clockwise direction. So I just showed you some positive directions, but if we wanted to do a negative one, let's take that example that I showed you that said, I said it was 330. So let's do that 330. You're saying that this is 330 degrees. And this counterclockwise is the typical direction in which we go. But some people would prefer to say, well, this angle looks a lot more like what I'm familiar with. So we know that the full circle is 360, so it makes sense that this would be 30, but when you talk about it on a coordinate graph, you're going to want to call that negative 30 degrees. Alright, so let's do some examples. Locate 125 degrees in standard position. So 125 is in between 90 and 180. And so 125, just kind of draw a line that's somewhere in between there. You don't have to know exactly where it's at, but this could be approximately 125. So you know that that's going to be here in quadrant 2. Okay, if we do negative 100, so now we're going negative, so you are going to go in the clockwise direction. And remember that each axis is 90. So this is negative 90. Negative 100 is bigger than that, so that's going to have to be somewhere over here. So negative 100 would be somewhere over here. This would represent negative 100. So that's in quadrant 3. Alright, so you consider two angles coterminal if they terminate in the same place. So coterminal angles, when we're talking about degrees, will differ by 360 degrees. So what I mean by that is right now all I've talked about so far is 0 to 360. So if I take this example of 200, it's in between 180 and 270. So that's somewhere right here. So this is considered 200. Now, let's say you take this segment and you go a full circle around again. So if I've gone a full circle around again, then I've gone 360 more degrees. So that's why, because you've gone a full second circle, that's why it's going to differ by 360. So that's saying you're going to go, it's going to be a total degree of 560. Now let's say, go back to the original 200, this original 200 that was right here in the blue. Now let's say instead of going in the positive angle direction, let's take that and go in the negative angle direction. So now we're going clockwise this way. So now I've gone 360 less than that. So 200 minus 360 is negative 160 degrees. Okay. Negative 500. So negative 500 is in the negative direction. So you're going to go clockwise. If you go clockwise a full circle, you've gone negative 360. So this is representing negative 360. If you go 90 more, that's negative 450. If you go 90 more, that's negative 540. So that's past it. So it's got to be somewhere in here. So this represents, I should do that in a different color. This represents negative 500. Now if I want a positive and a negative, think about the fact that negative 500 is a number that's a pretty big negative number. If you add 360 to that, you're still going to be negative. So negative 500 plus 360 is negative 140. So that's an example of a negative coterminal. If you add 360 to that, it's going to be 220. And then a quick check you could do is just to make sure that those are actually also in quadrant 3, and you could confirm that pretty easily. Alright, so 530. Why don't y'all do 530 yourself? You can push pause at this moment to do that. So if you did 530, you should have an answer by now. So 530 minus 360 is 170. So 170 is one positive, and then 170 minus 360 is negative 190. Okay, the more traditional way to talk about angles is the use of radians. And radians is just a different way to talk about angles rather than using degrees. So let me first explain why a radian is how much it is. So if you think about what you know about circles, circles is equal to 2 pi r. And when you say that the circumference is equal to 2 pi r, you've gone the full circle around. So if you go a full circle around, you've gone 360 degrees. Now let's just assume that you're using a radius of 1, so I'll call this 1. So really 2 pi times 1, I can just really erase that 1. Well, if I knew how to erase it. Okay, so I don't know how to erase it. So just take this, if you multiply times 1, it's 360 equals 2 pi. So what that means is that if you wanted to convert from radians to degrees, you can use 360 over 2 pi. So here's your conversion. you can convert from degrees to radians by multiplying times pi over 180, and radians to degrees multiplying by 180 over pi. It's not really something I recommend memorizing. Instead, I recommend understanding if you're going from degrees to radians, then you want to see a pi. So pi is going to have to be on top. If you're going from radians to degrees, you want to get rid of the pi, so the pi has to be on bottom. So in order to demonstrate this, let me look at example 4. So 7 pi over 12. And what I'm trying to do is convert the radian to degree. So 7 pi over 12 represents some degree. We want to know what degree that represents. So if you want to know what it represents in degrees, you do not want to see a pi. So we've been practicing fractions for the past couple of days. If you don't want to see this pi, you need to put a pi on bottom. And if you can think about that, then you know if the pi is on bottom, then 180 must be on top. This cancels with this. Okay, let's see. Let's do some mental math here. 12 is 6 and 2, and 180 is 6 and 30. So those 6's cancel. So that's 210 over 2. I don't know why I chose that. And then 105 degrees. Okay, so let's do B. Negative pi over 10. So same thing. You want to multiply times the pi on bottom. That way, pi gets rid of pi, and you're going to do 180 on top. So this cancels with this, and you're left with negative 18 degrees. All right, now we're going the other way, though. If you want to go from degree to radian, this means you want to see pi, and you want to see regular pi. So you're going to put pi on top. I am going to put this over 1 because I know I'm about to use fractions. So this cancels with this. If you're having trouble with this mental math, you need to really think about how 52 breaks up. So they're both at least even numbers. You can do that. So that's 2 times 26, and this is 2 times 9. So the 2's cancel. So that's left with, is that it? 26 over 9? So negative 26 pi over 9. Okay, so let's do another example. 320 over 1. I want to see pi, so I'll put it over 180. Once again, I'll just cross off a 0 for 0. It's like crossing off 10 over 10. 32 is 4 and 8. 18's not 4 and 8 though, so I'll have to use something different. So let's use 2 and 16, I guess, and 2 and 9. So 2 cancels with 2, leaving me with 16 pi over 9. Okay, just like with degrees, we do have some coterminal angles in radians. Keep in mind, coterminal angles in degrees was 360, and so since 360 equals 2 pi, when we're talking about radians, they're going to differ by 360 degrees, but in radians, that's 2 pi. So I'm going to subtract 2 pi here. So this is practice of fractions. You have to have common denominators to add and subtract fractions. So right now, my denominator is a 1. I'm going to again use that magic number of 1 I keep talking about. Multiply 3 over 3. So this is really like 11 pi over 3 minus 6 pi over 3. So that's 5 pi over 3. So this is 1 coterminal. I still don't have a negative 1, so I'm going to subtract again. So 5 pi over 3 minus 2 pi. Wait a second, I don't want to use 2 pi, right? This is the same problem. You don't want to use 2 pi because you need a common denominator. So let's go ahead and use 6 pi over 3. So I'm going to cross this off. 5 pi over 3 minus 6 pi over 3 is negative pi over 3. So this is an example of a positive coterminal. This is an example of a negative coterminal.